particles in solution. Yes, when it's that. Now, if we were doing this for any of these guys, I would have to triple for this one because there's 3 for 1. I would have to quadruple 4 for 1 on this guy. There's 1 of each here, so there's 2 for 1. 1 copper, 1 sulfate. So that doubles the molality. No, it's 1 before it goes in the water. When it goes in the water, then it's double. So when we calculated the molality, we used 1 mole of this stuff not in the water. So the molality, when we put it into the water, is not going to stay the same. It's going to double. And now we have 0.596 times 2. Okay, so that's 1.192, and that's the molality of the particles, not the molality of the copper sulfate anymore. Now we use this guy for our molality, and we go back to our same little charts, and we figure out what the freezing and boiling point changes are going to be. So I'll do this in the same order that I did the last ones. Go to page 474, and we get for water that the K sub F, this is the change in freezing, is equal to 1.86 degrees centigrade per molality. Yeah, this is a tough problem. And then we're going to take this molality. Okay, we had to double the original molality that we had. Yes, this is 1.92, and that's little m, and that's over 1. Now the calculation gets simple again. Okay, so we're going to take now and run our numbers, and we got 1.86 times 1.92, and that gives us 3.57 is the degrees centigrade that the freezing point is going down. Now let's do the change in melting. Yes, yeah, they both have to be the same. The difference is we have to go to another chart. Yes. Huh? You're right. It is. 1.192. Yes, thank you. And so that's 1.192 times 1.86. There we go. You get 2.2? Yeah, okay. So we got 2.22 if we round. And that is our change in the freezing point. So that's our first dude. And the change in the melting point coming off the melting point chart is back on page 470. Whoops. 472. And the K sub B for the melting point is boiling. I'm sorry, we're working on boiling point. Change for the boiling point is 0.512. 0.512. Notice it's much smaller than the freezing point is, the change per molality. And then our molality again is going to be 1.192. Got it right this time, huh? And that's over 1. Molalities cancel, as they did up here. I didn't cancel them out. And that's going to be equal to 0.512 times 1.192. Did I get that right? Yeah. So that one is 0.61, and that's fine for that, degrees centigrade. Now, we go back to the melting and boiling points of water. which we don't need to look at a table for. Yeah, I know. Here, let's see. For the new freezing point, new freezing point of water, instead of 0 degrees centigrade, the freezing point, we're going to subtract what we got here, 2.22. 22 or 20? 22. 22 degrees centigrade, and that's going to give us a minus 2.22 degrees centigrade. So that's changed the freezing point. A new melting point. New melting point is going to be, melting point is 100 for water. Boiling, yes. I said melting? Sorry. Meant boiling. Freezing. Boiling. Here we go. Boiling point, and our new boiling point is going to be adding 0.61. 0.61 degrees centigrade. And so that's going to come up to 100.6 degrees centigrade.
Which number is this?
These are our two answers. All of that, yeah, we started here. We had, see, what we had to do is get the moles,
That's a long problem.
and then we had to calculate the molality, and then we had to find the change in the freezing point and melting point. Now you see, this is where we started with the last problem, and then we had to go down and do exactly what we did in the first problem. Okay, that's it.